And take a look at this. NASA's James Webb Space Telescope has captured unprecedented pictures of a newly discovered exoplanet.
The James Webb Space Telescope has just sent back an image that's making astronomers do a double take. Out in the cosmic dark, floating in the cradle of a brand new star system, it found this, a new world caught in the very act of being born. And this isn't just any planet. Scientists are calling it a baby Saturn, a gas giant with a mass very similar to the ring jewel of our own solar system, has been directly imaged for the very first time by Webb. Now, to be clear, we aren't looking at a simulation or an artist's best guess. While not a photograph in visible light, this is the real deal, a scientifically processed image from Webb's powerful infrared eyes, capturing the actual heat signature of this new world. So what can this incredible find, this infant world, tell us about the chaotic and beautiful birth of our own solar system, of Jupiter and Saturn, all those billions of years ago? The answer could change everything we thought we knew about how planets are made. Let's get formally introduced. Say hello to TWA7b. Okay, the name doesn't exactly roll off the tongue, but trust me, it's one that will be written in astronomy textbooks for decades to come. This find represents some of the most compelling evidence yet for Webb's first exoplanet, discovered using a technique called direct imaging. For years, we found thousands of exoplanets by watching for their shadows, that tiny dip in a star's light as a planet crosses in front. It's effective, but it's like knowing someone is in a room just by seeing their shadow under the door. Direct imaging is kicking the door wide open. Webb has taken an actual picture of this distant world's heat. TWA7b is what's known as a gas giant, estimated to have a mass of 1/3 of Jupiter's, putting it squarely in the same weight class as our Saturn. It orbits its star, a young red dwarf named TWA7, from a huge distance, about 50 times farther than Earth is from the Sun. If you plopped it into our solar system, it would be drifting out in the lonely, frozen darkness of the Kuiper Belt, way beyond Neptune. But unlike the cold, ancient giants of our system, TWA7b is young and still glowing with the heat of its own formation. It's a planetary infant, orbiting a star that is only about 6 million years old, a mere toddler compared to our 4.6 billion-year-old sun. This isn't just a discovery, it's a baby picture, and it's the clearest one we have ever taken of a world like ours in the making. So how exactly did Webb pull off this incredible feat? Spotting a planet right next to its star is one of the toughest challenges in astronomy. The problem is simple. Stars are blindingly bright, and planets are incredibly faint. As one lead astronomer on the project put it, the basic problem is that the star is bright, and the planet is very faint. It's like trying to spot a firefly hovering next to a billion-watt searchlight from miles away. The glare is just overwhelming. To get around this, Webb used two of its secret weapons, its mid-infrared instrument, or MIRI, and a device that sounds like something straight out of science fiction, a coronagraph. A coronagraph is essentially a high-tech star shield. It's a tiny, precisely engineered mask that Webb can place right in front of the star's image, blocking out most of its overpowering light. With the star's glare suppressed, the faint glow from objects around it can finally be seen. Even then, it's not perfect. The team had to use incredibly sophisticated software to subtract the remaining starlight. But when they did, slowly, a faint orange dot of light emerged from the darkness. A dot that wasn't a background star or a distant galaxy, a dot that was moving right along with the star TWA7. It was the planet itself. This technical achievement is a landmark moment. It proves Webb has the power to not just study planets, but to hunt for them directly. This is likely the lightest exoplanet ever to be directly imaged, estimated to be 10 times less massive than any planet photographed before. It's a stunning testament to the telescope's power and a huge sign of what's to come.
All right, so we found a new planet. What makes this one so special? Why are astronomers so fired up about it? The answer is all about context. TWA7b isn't just a lonely world floating in space. It's an active participant in the creation of its solar system, and it's giving us a front-row seat. Think of it as a cosmic time machine. We can't go back 4.5 billion years to watch Jupiter and Saturn form. We have theories and computer models, but we've never seen it happen until possibly now. By looking at the TWA7 system, we're getting a glimpse of a story very much like our own solar systems, just in its early chapters. One of the most exciting parts is where they found the planet. The young star, TWA7, is surrounded by a massive disk of dust and debris, the leftover building blocks from the star's birth. Ground-based telescopes had already seen that this disk wasn't smooth. It had distinct rings and gaps in it, like grooves on a vinyl record. For years, scientists have theorized that these gaps are carved out by the gravity of forming planets sweeping up material. It was a great theory, but a theory nonetheless. TWA7b was found sitting perfectly within one of those gaps. This is the smoking gun. It's the first time we have strong evidence of a directly imaged planet being linked to sculpting its own home disk. This baby Saturn isn't just growing, it's a planetary architect, a gravitational sculptor shaping its own environment. It's actively building its solar system, and we get to watch. And then there's the temperature. Initial analysis from Webb's instruments suggests the planet's temperature is around 47 degrees Celsius, or 120 degrees Fahrenheit. While that sounds warm, for a young planet, it's actually considered quite cool, and this temperature gives us vital clues about how it formed and where it is in its life story. Every piece of data from this one world helps us refine our models of planet formation and helps us answer fundamental questions about our own origins. A discovery like this doesn't just provide answers, it opens a universe of new, even more exciting questions. The work on TWA7b has only just begun. First on the to-do list, study its atmosphere. Using Webb's powerful tools, scientists will try to figure out what this infant world's air is made of. Does it have the hydrogen and helium we'd expect? Are there other surprises mixed in? Its atmosphere is a window into the raw ingredients available for building a gas giant. Then there's the tantalizing possibility of moons. Our Saturn has a stunning collection of over 140 moons. If TWA7b is truly a baby Saturn, is it possible it has baby moons forming in a disk around it right now? The idea of witnessing not just a planet, but an entire moon system being born is a mind-blowing prospect that Webb may actually be able to investigate. Scientists are also on the hunt for something called a Trojan disk, a swarm of dust and debris that could be trapped in the same orbit as the planet, moving along with it like a cosmic convoy. Finding a feature like that would be another incredible first, offering even more direct evidence of how these planets boss around the material they are born from. But maybe the biggest question is, what's the limit? TWA7b is the lowest mass planet we've ever directly imaged. This discovery proves Webb can find planets much smaller than the giant hot Jupiters we were limited to before. This is a huge leap. It opens a new window for finding planets that are more like the ones in our own cosmic backyard. If Webb can snap a picture of a Saturn-mass planet today, what could it find tomorrow? A Neptune? Maybe one day an Earth. Each discovery pushes the boundaries of what's possible and brings us one step closer to understanding our place in the universe. The evidence for TWA7b is more than just another pin on the cosmic map. It's a story. The story of a world's birth, one that mirrors the birth of our own home billions of years ago. For the first time, we have a direct image of a Saturn-like world in its infancy, actively shaping the system around it. It is a stunning showcase of the James Webb Space Telescope's power and a promise of the revolutionary discoveries still on the horizon. We are no longer just looking at the stars. We are watching new worlds being born. The universe is full of incredible stories, and with Webb, we're getting to read them one page at a time. If you want to be there for the next big revelation and continue exploring the cosmos with us, make sure to subscribe and ring that notification bell. You won't want to miss what we find next.